This is a problem that involves two different particles, and it says that an elevator is moving upwards at a constant speed of 4 meters per second. So important information is it's moving at a constant speed, 4 meters per second, and a man standing 10 meters above the top of the elevator throws a ball with a speed of 3 meters per second, and we're asked to figure out when the ball will hit the elevator, which is a time, and where the ball will hit with respect to the man, which is a distance. And if we draw a picture of what we're looking at, we have an elevator right here that's moving upwards with initial speed of 4 meters per second. And a man is standing on a ledge and throws a ball up, and it falls down and at some point hits the elevator. And that we don't know if it hits below the man, where the man's standing, or above where the man's standing, but it hits at some point. Other pieces of information that we know, and that gravity is going to be acting on the ball, and we're going to call up our positive x direction and our positive velocity, and the ball has an initial velocity going up. We are also going to call the ledge that the man is standing on our 0 position. So this is going to be x is equal to 0. And what does that mean? That means the top of the elevator is located at a position x is equal to minus 10 meters. And if we write down everything that we know for both the ball and the elevator, we'll have an idea of how to solve this problem. So with the ball, we have an initial velocity of v0 of 3 meters per second. The elevator has an initial velocity, which is also its final velocity, of 4 meters per second. The ball starts at a distance of 0 meters. We're going to assume the man throws the ball starting at the ground. And the elevator starts at an initial position of minus 10 meters. The distance the ball is unknown. Where the ball, how far the ball travels, and the distance the elevator travels is unknown. And because wherever they hit, they're going to hit, and they're going to be at the same position, this x of the ball and this x of the elevator are equal to each other. They're going to be the same position. And we also don't know the time. We don't know how long the ball will be in the air until it hits the elevator. So we don't know the time, how long the elevator will be going up. And again, these two quantities will be the same. The time that the ball is in the air before it hits the elevator is the same amount of time the elevator is moving up before it hits the ball. And another piece of information we know is the acceleration. The acceleration of the ball, because it's gravity and it opposes our positive convention, which is up, we know that gravity is minus 9.81 meters per second squared. And the elevator, which moves at a constant speed, it means it has no acceleration. So we can look at our kinematic equations, and we have them right here. Our velocity is equal to an initial velocity plus acceleration times time. Distance is equal to an initial distance plus initial velocity times time plus 1/2 acceleration times time squared. And a final velocity squared is equal to an initial velocity squared plus 2 times the acceleration times a final position minus an initial position. And since we're interested in time, we're interested in finding time, we don't want to use this equation. And if we don't know a final velocity for the ball, so the best equation to use is this equation right here. And if we're going to have this equation twice, it's going to be one equation for the ball and one equation for the elevator. So if we have the x of the ball is equal to an initial position, which is 0, right here, plus an initial velocity, 3 times time, we don't know the time, plus 1/2 times a minus 9.81, which is our acceleration squared. And for the elevator, we have the x of the elevator is equal to an initial position, which is minus 10 meters, plus an initial velocity times time, which is 4 meters per second times time, plus 1/2 acceleration times time squared, but our acceleration is 0, so this part of the equation goes away for the elevator. And one last thing is, we've already said that the location of the ball and the location of the elevator are the same thing, so we can equate the location of the ball with the location of the elevator. And by doing so, these two are the same, so we have 3t plus 1/2 times minus 9.81 squared is equal to minus 10 plus 4t. And we can use an equation solver or a calculator to solve for t, and we get two roots. We get t is equal to minus 1.5 or 1.33 seconds. And for us, this minus 1.5 doesn't make any sense, so we'll throw it out. So we know that the ball in the elevator hit at 1.33 seconds after the ball is released into the air. And so this is our answer to part A. Now, part B, where will the ball hit with respect to the man? We can take how long the ball is in the air, and we can plug it into either one of these equations and figure out the location of the ball or the location of the elevator. Both the equations will give the same value. So for part B, if we say minus 10 plus 4 times 1.33 is equal to a location, we have the distance is minus 4.68 meters. And what is this saying? This is saying that the ball in the elevator will hit at a distance 4.68 meters below where the man is standing. So this happens below the man. And it's a negative sign because we've said our 0 coordinate is right where the man is standing. If it had been a positive 4.68 meters, it would have meant that the elevator and the ball collided above where the man was standing. But since it is a negative sign, it's below where he's standing.